In this section, we were talking about functions of random variables and specifically nonlinear functions of random variables, which makes them more complicated. Okay, so I've written here just to remind us, if we wanted the expected value of x, we took the integral of x times f of x dx, where f of x is a PDF. So if we want to find the expected value of some function of x, say h of x, we would take the integral of h of x times f of x dx, where again this h of x would be our function of x, or our function of interest, and f of x is the PDF. So with that in mind, let's go ahead and try these problems. So we have a random variable x with a PDF f of x equals 1/2 for x between 2 to 4. That's a very simple PDF. And we're interested in the function y equals 1 over x. So let's find the mean of y. So we want to find the mean of y. We're looking for the expected value of y. But y is really 1 over x. So we're really looking for the expected value of 1 over x. So to find the expected value of 1 over x, we will just integrate and we put in our 1 over x times the PDF. Okay. So this is our function of interest. This is our PDF dx. Now, when we do this, we need to integrate from 2 to 4. You always keep your bounds the same. Okay, so from 2 to 4. This is going to give me 0.3465. So that's the expected value of y, where y is a transformation of x. Now let's find the CDF of x. Okay, so not y, just x. So to find the CDF of x, we would integrate f of x. So capital f of x is always equal to the integral of little f of x. So in our case, we'll integrate. You start with your bottom bound, and you go to x, you put in your PDF, and you integrate with regards to some dummy variable, let's say t. And this is going to give me 1/2 x minus 1. Or in other words, f of x is equal to 1/2 x minus 1 for, and keep your bounds the same, x is between 2 to 4. And so there's my final answer for my CDF. We went from our PDF to our CDF. Let's just make a note. PDF to CDF. Now we want to find the CDF of y. There's kind of our little trick we do here. So to find the CDF of y, okay, what we want to find f of y. Now we put a capital Y here to tell us that y will be our variable of interest, little y is our specific number. So that PDF will be equal to the probability that capital Y is less than or equal to little specific y. This is equal to the probability. Now capital Y is equal to 1 over x. So 1 over capital X is less than or equal to little y. And at this point, so we substituted 1 over x for y, or y equals 1 over x. Now solve for x. So just keep going. Remember, it isn't an inequality. We want to solve for x. Notice our x's are always positive, so we don't have to worry about our signs switching if we're multiplying or dividing by negative. So I'd multiply both sides by x, so we have 1 is less than or equal to y times x, or I now divide by the y, so we have 1 over little y is less than or equal to capital X. And this is equal to the probability that capital X is greater than or equal to 1 over y. Now at this point, okay, we have our x, which is what we want, but this is a greater than or equal to. I don't want that. I need a less than or equal to make a CDF. But we know how to use the complement rule. Complement rule. And the complement rule says the probability that x is greater than or equal to something is equal to 1 minus the probability that x is less than or equal to the same thing. Okay. So this was just our complement rule. Okay. Now this piece right here, probability that x is less than or equal to something, is by definition the CDF of x. Probability that x is less than or equal to something. So this is going to be 1 minus the CDF of x. You can put the x there to remind you it's the CDF of x. And we have the value 1 over little y. That might seem very complicated, and we're not quite done. Okay. At this point, we want to know what is the CDF of x at the point 1 over y. So we'll do 1 minus. Now find the CDF of x again, which is, CDF of x is 1/2 times x minus 1. So 1/2 times x. Now in this case, x is 1 over y minus 1. So we plug 1 over y into the CDF of x. Let's see, so 1 minus a negative 1, that should give me a positive 2. So we have 2 minus 1 over 2y. We're unfortunately not done quite yet, because this is the CDF of f, but we also need our new limits. Let's switch colors here. Okay. So we say if x equals, let's see what were our limits, 2 to 4. If x equals 2, then y equals 1 over x, which is 1 over 2. So 1/2. And if x equals 4, then y equals 1 over x, or 1/4. So my new limits are 1/4 to 1/2. Notice they did just kind of switch of which one comes first. That's okay, doesn't really throw us off. So our final answer is that our CDF of y is equal to 2 minus 1 over 2y for y between 1/2, y is between 1/4 to 1/2. So it does take a few tricks, it takes a lot of practice. But we did find the CDF of y. Now let's find the PDF of y. So we know the CDF, we want to go to the PDF. When we're working with multiple random variables like this, you always label everything with your x or y, so you know what you're talking about. So we want to find the PDF of y, so we're going to say it's little f, capital Y, so I know which variable I'm talking about. And to find that, you just take the derivative of the CDF of y. So let's take the derivative of what we just found, which is our 2 minus 1 over 2y, which is 1 over 2y squared. For y, once again, between 1/4 and 1/2. And finally, not finally, let's find the expected value of y. Notice we did already find this in part 1, but let's do it using our PDF of y now. So the expected value of y is just equal to the integral of y times f of y dy. Or in this case, the integral of y times 1 over 2y squared dy from 1/4 to 1/2. We can go ahead and put this into our calculator or do it out yourselves, and you get 0.3465. Notice this does match what we found in step 1. And number 6 is find the probability that y is between 1 and 2.5. This is actually kind of a trick question because the bounds are that y can only be between 1/4 and 1/2. So what's the probability if you're outside the bounds? 0. So the probability that y is between 1 and 2.5 is just 0. You don't even have to do anything, you're outside of your y bounds.